This video is part 3 of a video series on the automation of the Accu-Slice system. In parts 1 and 2 of this video, we describe the hardware and software needed to operate the system. In this video, I'll be doing some exhaustive tests on actually cutting boards on the bandsaw using this automated Accu-Slice system. In this first series of tests, I'll be cutting this 1.5 inch thick piece of cherry, and I'll be cutting slices of boards 25,000 of an inch thick. And I'll be cutting these slices at different cutting speeds, from probably as low as 10 inches a minute to maybe up to 100 inches per minute, to evaluate the cutting surface as a function of cutting speed. In the past, when we were doing this cutting manually, we did observe that the slower you cut, the smoother the cut. Apparently, by cutting more slowly, the bandsaw blade teeth are acting like a planer and actually smoothing out the surface from the previous cut. Some of our customers observed something similar when they had their bandsaws running at higher speed. Some bandsaws have multiple speeds for operation. By operating at higher speeds, they got smoother cuts. My bandsaw only has a single speed, so I'm not able to do that, to verify that. But I will be able to verify the cutting speed as a function of speed through the bandsaw blade. Also, as part of that study, I want to look at parallelism of the cuts. Since I've added additional weight to the left side of my rail here, I'm concerned that this may cause the blade to move slightly. So we'll be evaluating that to make sure our boards are perfectly parallel. In the final series of tests, I'll be cutting boards of different thicknesses. I'll be going from this 1.5 inch board up to possibly a 12-inch tall board to see if this stepper motor has enough power to pass the boards through the bandsaw blade. If I do need to go to a bigger stepper motor, this could present some problems. This is a NEMA 23 stepper motor. The next size up is a NEMA 32, which has 4 times the power, but it's also 4 times the weight, and that could present a problem on having that large of a motor on the left side of the rail. So hopefully we don't need to do that, but if we need to do it, we'll evaluate that going forward. To start out, I just changed the blade on my bandsaw blade. I wanted to start with a new blade so I can evaluate this more accurately. I installed a 1/2 inch wide blade. This has 8 teeth per inch. Normally when I'm cutting a board this size, I'd probably use a 10 teeth per inch, but I wanted to go a little bit coarser blade to see what kind of results we get. For this first series of tests, I'll be using this piece of cherry. This cherry is about 1.5 inch thick, about 1 3/4 inches wide, and I'll be cutting slices of thin strips of wood off of this, about 25,000 of an inch thick. And I'll be cutting these at different speeds, all the way from maybe as low as 10 inches per minute up to 100 inches per minute, and then comparing the surface finishes on those boards, and also checking the parallelism of the cuts as I make the slices of wood. So first of all, I need to set up my system to align up properly with the bandsaw blade to get my first cut, and that's where these jog positions come in handy. So I could use my automatic feeds, but then you got to get it to stop in the exact right place. So it's easy using the jog buttons. You can jog it into position, and then you can adjust your mag jigs to adjust your system to get it accurately positioned, and lock it in place, and move it back with the jog again. And then I would release my mag jig clamps, do 1 full turn for the curve of the bandsaw blade, and then like I said, I'm cutting a board 25,000 of an inch thick. And then lock my mag jigs in place. And now we're ready to cut our first board. So for this first board, I think I'm going to set it to around maybe 30 inches per minute. It's probably a good speed that I normally cut at. So we'll do that first test. So let me move this back first of all so I can adjust my jog position. Now I'm going to set my speed. And I know that around 2 on my dial here is around 30 inches a minute. So let me start this running and I'll check my speed and adjust this if I need to. So right around 29 inches per minute, which is close enough. So let me go ahead and start the bandsaw blade. Okay, I'm going to start out here showing this at the actual running speed. But this is not speeded up at this point. But then I'll increase the video speed 10 times the actual speed so it doesn't take so long to view this. Now to return this board to the left side, I don't want to send it back at the same speed. I want to get a faster speed so I'm not waiting so long to get it back to the starting position. So I can jog this much higher. I can go up to 150 inches per minute, but if I turn this to 150 inches per minute, it's going to stall out the motor. It can't handle that much at a startup. So what I knew, I normally start at the same speed that I ran it through the bandsaw blade at, and as it's going, I increase the speed to get it to go back faster. So I started running by pushing the left button, and then increase the speed. And that's 150 inches per minute. And then stop it. And there's my first board off the system. And let me mark that surface. So this was 30 inches per minute. And you see that surface, it's pretty smooth. I can see some minor saw marks, but there's no burn marks and no deep cuts, but it's pretty smooth. And let me check the parallelism of this board. So I have 20 thousandths, 19 and a half 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 thousandths. So between 19 and a half thousandths and at the most 20 thousandths of an inch thick. So it definitely is parallel. I said that is 30 inches per minute. So let me start back at my setting of 10 inches per minute, which is my starting point that I want to try for running the system. So now I'm ready to cut my first cut, and I'll be cutting this at 10 inches per minute. So let me release my mag jig clamps. One full revolution for the curve of the blade, and then another 25 thousandths. And then let me verify that with a timer so we can see how long it's going to take to cut this board. So theoretically it should take about 3 minutes, a little over 3 minutes to cut this 36-inch long board. Well, the speed of cutting that on my computer was around 10.4 inches per minute. It took almost exactly 3 minutes to cut this board. So let me mark that surface. This is 10 inches per minute, which is really slow. But that's a pretty smooth surface. And you can see the almost no saw marks in it at all. So let me check the parallelism once again. So I got 24 thousandths, 24 thousandths, 24 and a half thousandths, 25 and a half thousandths, and 25 and a half thousandths. So the parallelism is good. So that's my 10 inches per minute, and this is my 30 inches per minute. And the 10 inches per minute definitely is better, but not a whole lot. The 30 is still pretty good. So let me go run at 20 inches per minute. So these are our new settings at 20 and 30 inches per minute. And they look very similar, but as I feel these boards, I can feel more at the 30. So the 20 are definitely smoother. I mean, it's hard to see the difference, but I can feel the difference. So 20 is the number I like. You know, I'm running a lot of boards here. I do want to cut the entire board because, you know, this is a test of the system. So you don't do a test by running 1 or 2 boards. You run a test by running, 100 or more boards. So I'm going to get quite a few boards cut on this system. So let's go with our 15 inches per minute and see what we look like here. Now going down to 15 inches per minute, I see no difference between the 20. So it's probably not worth spending extra time cutting. I continue cutting the cherry board at speeds of 40, 50, 60, 70, 80, 90, and 100 inches per minute. This final cut is actually 100 inches per minute, and I'll show this at actual speed. Said I would never cut that fast. That's really moving it to the bandsaw blade. My cuts going forward, I think I'll probably use between 20 and 30 inches per minute. This concludes this test of part one of this test for the automated Accu-Slice system. And off that piece of cherry, which started out with about 2 inches thick, I did cut 24 pieces of cherry, 25,000 inch thick, and at different speeds. The parallelism was perfect, right on, for all these boards. There was no issue at all. They were within actually half a thousandths from one end to the other. Right on. Cutting speeds, I determined that the best cutting speed is between 20 and 30 inches per minute. You know, of course, the slower you get, the smoother the cut. You know, 10 and 15 give very smooth cuts. But practically, 20 to 30 is probably a good range. Once you get above like 35, then it starts getting a rougher surface. For this study, I did slice boards from 10 inches per minute up to 100 inches per minute. And I just did some photography here, and I put a low light angle so you can actually see the saw marks in the boards. So you can see the improvement going from 100 inches per minute going all the way down to 10 inches per minute, with the 10 inch, of course, being the smoothest. But 20 to 30 inches per minute seems to be a good cutting range for slicing these boards. In this next series of tests, I want to cut some taller boards, going from the 1.5 inches, which I did already, all the way up to 12 inches tall, to see if the stepper motor has enough capacity to pass these thicker boards through the bandsaw blade. Hopefully I don't need to switch to a larger stepper motor, but I need to determine that. So I said we'll be cutting some different woods, some different heights, some different thicknesses, and seeing how the system works. Now I did do an initial test with my 8 teeth per inch blade. It was on there from the previous test. And these taller boards just gummed up that blade. So I took that blade off and I switched it to this blade. This is a 1/2 inch wide blade, 4 teeth per inch. Now 4 teeth per inch is a little coarser than I normally use, but I'll be going some taller boards, and I thought I needed that 4 teeth per inch in order to cut those taller boards. So this first piece of wood is a piece of cherry. It's 6 inches tall, 1.5 inches wide, and I'll be cutting off some slices 25,000 of an inch thick. I'll be starting off with a speed of 20 inches per minute, which was the optimum speed we found in the previous test. But I may do some additional tests at some slower speeds, because I've always found that when you cut taller boards, you need to slow down even more. So we'll try that going forward also. So let me go ahead and do this first test. Again, this will be 20 inches per minute, cherry board with a blade 4 teeth per inch. Now that board cut through there with no problem. I was checking my amperage on my power supply for the stepper motor. I have a 4 amp stepper motor, but it was pulling less than 1.5 amps, so I have plenty of power. So I don't think power is going to be any problem for this stepper motor. So that piece came out pretty good. Not as good as the previous one, because it is a 4 tooth per inch blade. So let's see what kind of variation we get in parallelism on this. So 18.5, 19. And 17. That's 19, 19.5, and 19.5. So again, that's pretty good. Again, that was at 20 inches per minute. So let me go and cut another piece at, let's go down to 15 inches per minute, and then we'll follow it up with a piece at 10 inches per minute. Okay, that 15 inches per minute was a little bit better, but not a whole lot better than the 20. So next I'm ready to cut this piece of cherry at 10 inches per minute. Again, this is a piece of cherry. It's 6 inches tall by 24 inches long. Again, using the 4 teeth per inch bandsaw blade. So we're cutting this at 10 inches per minute, which is pretty slow. So from that piece of cherry, I was able to cut 20 boards, again 25,000 inch thick. No problem with the power and stepper motor. It was pulling less than an amp and a half for all those tests. And the parallelism of the boards is not quite as good as the smaller boards. It was probably plus or minus the thousandth of an inch over the length of the board. Again, this was a 6-inch wide by 24-inch piece of cherry. And this was cut with a 1/2 inch blade, 4 teeth per inch. And the blade's not gummed up, it's in good shape. This next board is a piece of maple. This board is 4 inches tall by 36 inches long. Again, I'm using the same blade, 4 teeth per inch, 1/2 inch wide blade. Well, I cut 2 boards there. The first one I cut at 20 inches per minute, and the second one I cut at 10 inches per minute. This is a pretty coarse blade for cutting a board this small. Normally I'd probably use an 8 teeth per inch blade, and this is a 4 teeth per inch blade. So cutting at 20 inches per minute, it's not bad, it's okay. But when going down to 10, it improved quite a bit. So you can use a coarser blade, just run a slower speed. But I'm getting no gumming up or clogging up of the blade at all, even after cutting all this wood I've been cutting. This board's a piece of hickory. It's a pretty hard wood. It's 7 inches tall by 30 inches long. Well, I did cut a total of 6 pieces of hickory off that hickory board. And again, that was cut with this 1/2 inch weight. That was cut with this 1/2 inch wide blade, 4 teeth per inch. And I did cut these at 10 inches per minute. I'm now ready to cut this piece of Purple Heart, again 9 inches tall. I'm going to be cutting this again at 20 inches per minute. Okay, that was the Purple Heart at 20 inches per minute. And that cut is actually smoother than the cherry. Very nice cut. I'm going to cut a couple more boards. I'm going to cut all these boards 50,000 inch thick because I'm going to be using these for a project. So from that piece of purple heart, I was able to cut 7 slices. Again, 50,000 inch thick, and the surface is really good. This next board is some cherry wood left over from the previous video I did of making guitar backs and sides. And this piece of cherry is 10 inches wide by 32 inches long. And this is a piece I cut previously. I cut this by hand, which I showed in that previous video. So I now mount the same board on here, and we'll give it a try, see how it does. But this again is 10 inches tall. So I got 3 cherry boards out of that piece of wood, and that cut pretty nice. Okay, I'm ready to cut my 12-inch tall piece of poplar, and I am cutting this at 15 inches per minute since it is taller. That worked out pretty well. Pretty nice surface. I mean, definitely has more saw marks than the small board, which I cut with the 1/8 per inch blade. But let me go and cut a couple more pieces. Get 50,000 of an inch thick. Okay, I did cut 6 boards off of that piece. Again, they're 12 inches wide by about 20 inches long. And just checking the parallelism real quick. .44, 47, 40. So a little bit more variation than the previous ones. 40, 40, and 39. So a little more variation in parallelism, but not too bad. So I'm convinced that the stepper motor now is fine for cutting the boards I need. In this automated Accu-Slice system, I wanted to give a good test to not just cut 1 or 2 boards, but to cut 50 to 100 boards to see how good it really was. And they could cut boards from 1 inch thick to 12 inches thick. So this is kind of a review of everything that I cut. I started off by cutting these 1.5 inch by 36 inch long pieces of cherry, and I cut 24 of these. Then we have these hickory boards here. There's 7 of those boards. They're 7 inches by 30 inches long, and I cut 6 of those. I have a maple board that I cut, which was 4 inches wide by 36 inches long. I cut 8 of those. I have a poplar board that was 12 inches wide by 24 inches long. That was our widest board. I cut 8 of those. Another cherry board back here, which was 6 inches wide. Excuse me, these were 10 inches wide by 32 inches long. I cut 4 of those. And I have a cherry board here that was 6 inches by 24 inches. I cut 18 of those. And the last board I cut was this purple heart board, which was, again, 12 inches by 24 inches. And I cut 6 of those. So all in all, that's over 70 pieces of wood I cut on the Automated Accu-Slice system. So I'm quite satisfied with its performance. It definitely will work. I'm convinced that stepper motor is probably a good size, and I can use that going forward. This concludes part 3 of this video series on the design and testing of this prototype version of the Automated Accu-Slice system. In this video I did an exhaustive series of tests to determine the optimum cutting speeds for cutting boards on a bandsaw, verifying the parallelism of the system, and also verifying that one can cut boards up to 12 inches thick using the system. However, this is a prototype version of the Automated Accu-Slice system. After using this system for the past few days, I determined a need for additional improvements in both hardware and software. As a result, we will continue to do additional work to develop this system. Once again, thank you for watching this video. If you have any questions or concerns or comments, please give us a call or drop us an email. We'd be glad to hear from you.